This is the problem we are going to discuss in this video. A connecting rod of length L may be considered as a strut with the ends free to turn on the crank pin and the gudgeon pin. Here this is the connecting rod is given. Here you can see the gudgeon pin, this is the crank. In the direction of the axes of the pins that will free to rotate around these axes, the gudgeon pin and the crank pin. However, it may be considered as having fixed ends perpendicular to that direction. If you take the buckling around XX axis, we can consider this connector rod having the fixed support because that is not free to rotate around X axis, but it is free to rotate in YY axis. Assuming that the Euler formula is applicable, determine the ratio B to H, B divided by H for the given cross section so that the connecting rod is equally strong in the both planes of buckling. This is the problem given. Here the cross section of the connecting rod is given. Here you can see length is equal B, the height is equal H, then this thickness B divided by 5, B divided by 5, this length is equal 3B divided by 5, then this height also given 2H divided by 5, then this one is 2H divided by 5, so then this thickness of the web is equal H divided by 5. This is the cross section given. This overall length is equal to B, height is equal H, this thickness of the web B divided by 5, this one also B divided by 5, so this length is equal 3B divided by 5. Then this thickness is equal H divided by 5. So then this length is equal 2H divided by 5, 2H divided by 5. To make the connecting rod equally strong in both the planes, the buckling load around the XX axis and YY axis should equal. YY. So that means if we take the buckling load, Euler buckling load around XX axis should equal to the buckling load, Euler buckling load around the YY axis. For this connecting rod, if you take the buckling around XX axis, that is like both in a fixed supported column, because gudgeon pin, if you draw the gudgeon pin in this cross section view, it's like this. You can see the gudgeon pin. This is the gudgeon pin. This connecting rod free to rotate around this gudgeon pin, that means YY axis, but it does not free to rotate around the XX axis. If you take the buckling of the connecting rod around the XX axis, that is like both in a fixed supported situation. For the both in fixed supported situation, the buckling load equation is given by the Euler buckling load equation. The P is equal 4 5 square E IXX E divided by L square. For this case, if you take the buckling around the YY axis, that is like a column with both in pin supported situation. The buckling load in this case is equal 5 square E I YY divided by L square. In this case, this two buckling load should equal. That means the 4 5 square IXX E divided by L square should equal to the 5 square E IYY divided by L square. Here we can cut elastic modulus, and 5 square we can cut, then L square we can cut. Then finally we are remaining with this equation, the 4 IXX is equal to IYY. In that way we have to select the parameters H and B. The 4 times IXX should equal to the Iyy. In that way, we have to select the B divided by H ratio. Okay, well, let's calculate the Ixx. So I'm going to divide this composite area to 3 areas. Let's take this area as 1, this area 2, this area 3. So I'm going to find the area 1 second mode of area separately, area 2 second mode of area, area 3 second mode of area, and I'm going to add these 3. If you take the area 1 over 12, the B divided by 5, H total height is equal to H into cube plus 1 over 12, the B, this length is equal to 3B divided by 5. The height is equal H divided by 5. So here you can see the third area also similar to the first area. So I'm going to multiply this by 2. This is the Ixx. By simplifying this equation, we can calculate the Ixx value. That is equal to 0.03373 B H cube. This is the Ixx. So then I am going to calculate the Iyy. When you are going to calculate the Iyy, I am going to calculate the total rectangular section area, second mode of area. So then I am going to subtract these rectangular sections I values. If you take the old area 1 over 12, the B H B cube minus here the 2 areas 1 over 12, this length is equal H cube then Iyy, we are getting Iy value is equal 0.06893 H B cube. This is Iyy. Okay, then I'm going to substitute these Ixx Iyy values in this equation. 4 times Ixx 0.03373 B H cube should equal to 0.06893 H B cube. So then by simplifying this equation, we are able to calculate the B is equal 1.399 H. So that means B divided by H ratio is equal 1.399. Okay, this is how we are solving this kind of buckling load problem. Okay, thank you. See you next time.